Hello friends, in this video we will see about probability and statistics. This is a series of video, so we will name this video as session 1. So in this session 1 we will have a look at the definitions and some intro about probability and statistics. So before going into the topic, this is just some philosophical note. Subjective and objective. So subjective refers to experiences, opinions and judgments that are influenced by personal feelings, perspectives or interpretations. So it is often associated with individual points of view, and objective refers to information, facts or observations that are unbiased, independent of personal opinions. So following information are going to be objective. So everything is going to be objective. So and the probability, everything, the series of video, everything will be objective basis, and it will be covering from basics to intermediate level, and each person will have their own opinion. So because this is all chance events, so whatever the opinions are, some timely breaks and notes could be taken apart from bookmarking or having it offline. Why I have included this phrase is because I am planning to have this video complete video of all the series of videos together as a single video, as a lengthy one. So this is a session, this whole presentation is being broken down into session. This is the session 1, and below is just a PPT presentation available. You can look for the term, whatever terms which are covered here. And if YouTube video, you can note down the time of pausing and play from there. This is all just you might be knowing, just for your own, just for the information I have shared this. Next, probability and statistics definitions. Probability is the branch of mathematics concerning events and numerical descriptions of how likely they are to occur. So on a scale of 0 to 1, how likely is an event to occur? 1 means that the event is going to occur definitely. 0 means it is not going to occur at all. In between 0 and 1, what are the chance of an event which is going to occur? So the larger the probability, the more likely an event is likely to occur. So statistics is the discipline that concerns the collection, organization, analysis, interpretation and presentation of data. In applying statistics to a scientific, industrial or social problem, it is conventional to begin with a statistical population or a statistical model to be studied. So all this content are mostly inspired from Wikipedia and from other internet resources, and content, like the basis of content is shared based on the book Probability and Statistics by Mendenhall. And next, sample space, sets, union and intersection. So this is a very basis of a set theory also it comes. So in set theory, set we define it as set. Here we name it as sample space. So the sample space is a set of all possible outcomes of a random experiment. It includes every distinct outcome that can occur, and if so, it is like no duplicates are allowed. And if the duplicates are allowed, it is called as multi-sets. For tossing a coin, for example, the sample space is heads and tails, and for rolling a fair dice, the sample space is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. That is what is the number which will be showing on the top when the fair dice is going to be rolled. Event is the subset of the sample space. It is if it is a specific collection of outcomes that are of interest in a particular context. So an event is a subset of the sample space. So what is the likelihood, what is an event which is going to occur, like heads is going to come, or what is the event of like an even number showing up or an odd number showing up on a fair dice. So that is an so if that is the case, we will tell 2, 4, 6 or 1, 3, 5. So that is the event. It is a subset of the sample space. And element is going to be an element of a set is an individual outcome or event. For example, if the sample space is the set of all possible outcomes when rolling a 6-sided die, an element could be the outcome 2. Union A union B, the union of two sets A union B is the set of all elements that are in both that are in A, in B or in both. If an element is present in both or multiple times, it has to be included those many times. Mostly it will not be there, because in normal cases, except for multi-sets, it is not going to be there. Like in A union B, is going to have the elements that are in both A and B. A intersection B is going to have the is a set of all elements that are common to both A and B. This is common to both A and B, and this is the union of A and B. And complement means it is a set of elements in the sample space that are not in A. So types of statistics. These inferential statistics. So inferential statistics are like where we put hypothesis and then we try to infer whether our opinion is matching as per the data, as per our conditions. Like 90 with 95% confidence, can I tell whether this can be accepted, this hypothesis can be accepted or not? And those kind of statistics are known as inferential statistics. Descriptive statistics are based on the data is going to be analyzed. What is the mean, median, mode, the variance, how is the shape of the curve? These things are descriptive statistics. And Bayesian statistics is like incorporates prior knowledge about a population. So what is the event after, what is the probability that after based on one event the other event is going to occur. So if that knowledge is going to be incorporated, then it is known as Bayesian statistics. And non-parametric statistics. Non-parametric is a type of statistical analysis that makes minimal assumptions about the underlying distribution of data. Usually the data will be considered as a normal distribution. Most cases when we come across a bell-shaped curve will be there. So that is normal distribution. Non-parametric is a type of statistical analysis that makes minimal assumptions about the underlying distribution of the data. So often these models are infinite dimensional rather than finite dimensional, as is parametric statistics. So multivariate statistics. Multivariate statistics is going to have cluster analysis and ANOVA. Many variables are going to be there. That's why it's known as multivariate statistics. In normal distribution and other cases, it is mostly we will use univariate. Univariate means only single variable. So next is time series analysis of statistics. So here the patterns are identified and over a period of time. And what is the probability of events? In probability of events, in combinatorics, combination doesn't count all possibilities. So in right side there is a combination formula is given. So NCK, we will read it as NCK within brackets NCK, that is equal to n factorial by k factorial into n minus k factorial. So combination doesn't count all the possibilities. It just considers only the combination, and permutation counts all the possibilities. So whatever permutations things are going to be there, whatever order matters in permutation, whereas in combination order doesn't matter. That's why in combination combination will be having a lesser number than permutation. So that's why it is going to have another additional factorial in the denominator. And in the context of statistics and probability theory, a distribution refers to the set of all possible values and their corresponding probabilities or frequencies within a data set or a random variable. It provides a way to describe the patterns, tendencies, and variability of the data or outcomes. So distribution is a set of all possible values and their corresponding probabilities. So it is as simple as that. Distribution is going to have everything. And here are two key ways to define a distribution. Probability of getting an event is evaluated. For example, heads obtaining. When coin tossed once, that is equal to 1 by 2. Probability of getting 2, 4, 6, that is 2 or 4 or 6. So when rolling a dice once, that is equal to when rolling a dice, what is the probability of getting 2 or 4 or 6? So that is equal to 1 by 6 plus 1 by 6 plus 1 by 6, that is equal to 3 by 6, that is equal to 1 by 2. In both cases, events are independent, they are not dependent on each other. So if they are going to be dependent, then the formula, the inclusion exclusion formula, if the events are going to be dependent on each other, then another formula will be used, and we'll soon see about inclusion exclusion principle. It is a fundamental principle in probability theory that calculates the probability of the union of two events, so A or B. by considering the probabilities of each event individually and then adjusting for the overlap between them. So the inclusion exclusion principle is expressed as P of A union B is equal to P of A plus P of B minus P of A intersection B. So for that, the right side the figure is there. It is A is one set and B is one set, the Venn diagram, and they are overlapping with each other. The shade, the where yellow is going to overlap with blue, that is the intersection part. So A union B, probability of union of events A and B, that is at least one of the events A or B occurs, and P of A is probability of event A occurring, P of B is probability of event B occurring, P of A intersection B is probability of intersection of events A and B, probability of that both events A and B occur simultaneously. So this is in usual normal Venn diagram, we will tell us n of A union B is equal to n of A plus n of B minus n of A intersection B. So we will count the number of elements which are there in A. We will count the number of we will count the elements in B. We will see what are the elements which are common to both A and B. And after adding the number of after adding the elements in both A and B, we will subtract the intersection elements. So here this is the same formula is being applied here in probability. The idea behind the inclusion exclusion principle is to avoid double counting the probability of outcomes that are shared between events A and B. By subtracting the probability of the intersection P of A intersection B, we correct this double counting. So the probability of A intersection B, it's reduces the whatever the count the event which has occurred in both A and B, we will reduce it. And P of this principle can be extended to more than two events as well. If there are going to be three events, so P of A union B union C. So here the formula is somewhat lengthy. So how means P of, it is not similar, like we can tell P of A plus P of B plus P of C minus intersections, all the three intersections. But finally one small addition is P of plus P of A intersection B intersection C. So proof of this is going to be there in the next slide, and the Venn diagram of this is here in the right side. And next, if you see, yeah, so here on the top right we see means the elements, how the elements are there, double counting is there for the number of elements. So for that the formula is given, how it works. So here A plus B plus C means we will get all the elements, we have to count all the elements which are there in A plus B plus C, and A minus A, and then we are reducing A intersection B, and then we are reducing B intersection C, and then B intersection C and C intersection A, and then finally we are adding A intersection B intersection C. So if we see means this is going to match the what is the overall set A union B union C. So that is going to be matched here. In the left side, if you see the formula for A union B union C, so that is A is X and B union C is Y. So that is equal to X plus Y minus X intersection Y. So that is equal to A plus B union C minus A intersection of B union C. So next we see means B union C, we have to split down again B plus C minus B intersection C. Again we have to take A intersection B union A intersection C. That is A intersection of B union C is nothing but in this way it comes. Then it will become X plus Y minus X intersection Y. So that X intersection Y is nothing but A intersection B intersection C. So final formula we will arrive at. So below we see the permutation and combination formulas are given for NCR and NPR, and union of two sets formula which we shared, which we saw previously. Thank you.